Hello there. This is Algebra 1 Level 3, Lesson 1.1, Part 1. Okay, and the title of this lesson is Operations with Numbers. Of course, you know what numbers are, but what is an operation in this context? Well, an operation, as you can see, the definition is right on your screen, is an action performed with numbers, an action performed with numbers. You have operated with numbers ever since you learned 1 plus 1 equals 2. You didn't know that's what you were doing, but that's what you were doing. The operation in that case was addition. Okay, 1 plus 1. You are adding. The operation is addition. Can you name the other operations that you've worked with? Let's put addition on the screen there. Okay. What are the other operations? Okay, I bet you have said subtraction, multiplication, and division, or I hope you said that anyway. Those are the four operations that you are used to using and you've used for years. Okay, well, sometimes you are given an expression that contains more than one operation. There's more than one operation to perform. The question would be then, what operation do I perform first? If there's more than one operation, what operation do I perform first? Well, mathematicians have developed a system so that everybody understands what is to be done first, so there is consistency throughout. Okay? And mathematicians use what are called, let me bring that up, symbols of inclusion. Symbols of inclusion. Okay, and you can see them here. Symbols of inclusion include parentheses, and I know that you are used to seeing parentheses. You may have seen them in math, but you certainly have seen them in writing. Okay, and then brackets. Brackets are these square corner things. Okay, and the last one you probably haven't heard of before. It's called a vinculum. A vinculum. Okay, and it's actually a division bar. Let me get my pen here. It's a division bar. So when we write the fraction, for example, 3/4, that line right here, the line that divides the 3 from the 4, is a division bar. It's actually division taking place here. And the official name for that is a vinculum. And this vinculum is a symbol of inclusion. The way this works as a symbol of inclusion is that you would perform all the operations in the top part of the fraction, called the numerator, and all of the operations in the bottom part of the fraction, called the denominator, before you would do the division. Okay? So do the work in the numerator, do the work in the denominator, and then do the division. So that vinculum acts as a symbol of inclusion to tell us what operations to perform first. Okay, so basically then, whatever operation is inside the parentheses or brackets or above and below the vinculum, those operations are performed first. Okay, so let's just do a couple of examples. All right, I'm going to write over here. Okay, let's say we have 4 plus 5 times 6, and I'm going to use parentheses as my symbols of inclusion. And remember, we are to do or perform the operation within the symbols of inclusion first. Okay, so inside the parentheses we have addition. We are to perform that addition. 4 plus 5 is 9. Okay, so this expression, and we'll talk more about that word a little later, this expression is equal to 4 plus 5, 9 times 6. This expression then is equal to 54. Okay? All right, let's do another one. I'm going to move my screen a little bit here. Okay. All right, how about this one? 4. I'm going to put my symbols of inclusion around the 5 and the 6 this time. Notice that I'm using exactly the same numbers I used in the previous example, and exactly the same operations as well, addition and multiplication. Everything is the same except the position or the placement of these symbols of inclusion. All right, so let's perform the operations here. This expression right here is equal to 4 plus, and now we're going to perform this operation. We're going to do the multiplication. 5 times 6 is 30. And now we will say 4 plus 30 is equal to 34. Okay? So, the placement of the symbols of inclusion make all the difference in the world, don't they? The different answers that we got result from the different placements of the symbols of inclusion. All right? But no matter where the symbols of inclusion are, no matter where, whether they are in the front of the expression or in the back of the expression, or if you have a real long expression somewhere in the middle, no matter where they are, we begin evaluating our expression there within the symbols of inclusion. Okay, I just used 2 words that you're going to hear a lot this year, and you need to know the meaning of these particular words. The words that I just used are these: expression and evaluate. I said no matter where the symbols of inclusion are, we begin evaluating our expression there. Okay, so an expression is a collection of numbers, operation signs, and symbols of inclusion. Okay, it's a collection of numbers, operation signs, and symbols of inclusion. So these particular these are expressions. This right here is an expression. It's a collection of symbols and numbers and operation signs. Okay? It is an expression. Okay? And the same is true for the one above it. This is an expression, but that is an example of an expression. Okay? There's one thing that an expression does not have. Okay? An expression never has an equal sign. Okay, let's take a look again at these 2 expressions. Right here, I'm circling it here. Do you see that? There is no equal sign. Do you see this one? There is no equal sign. An expression never has an equal sign. Now you say, well, what about these equal signs right here? Well, yes, we do use equal signs as we evaluate the expression, that is, find out the value indicated by the expression. We do use equal signs there, but the expression itself does not have an equal sign. Okay, and the same is true with this one. If you were to see a collection of numbers, operation signs, and symbols of inclusion with an equal sign, you would not have an expression. You would have actually an equation. And that difference is something that you do need to understand, and it does make a difference. We'll be using that throughout the year. Okay, and secondly, We've said the word already. Evaluate simply means to find the one number for which the expression stands, to find the value of the expression. And you can see that the word value is pretty much inside the word evaluate. So that's the way to remember the meaning of that word. Okay, so in our examples, we evaluated both of these expressions. This expression right here evaluates to 54. This expression evaluates to 34. Okay, that's about it for this video. In the next video, we will work a couple more examples together, and then you will do your assigned homework from your syllabus. See you in the next video.